Welcome to the Doherty Water for Food podcast. Since 2010, the Doherty Water for Food Global Institute at the University of Nebraska has worked toward one goal, a food and water secure world. One in which global food security is ensured without compromising the use of water to meet other essential human and environmental needs. It's a daunting vision, but one that is vitally important. This podcast amplifies the voices of those making waves in this space. We hope you enjoy today's episode.
Hello, I'm Frances Hayes, DWFI Director of Communications and Public Relations, and your host for this episode of the Water for Food podcast. I'm joined today by Yufeng, Santosh Pitla, and David Jones, all biological systems engineering faculty at the University of Nebraska-Lincoln. Among other things, the team has already conducted research in the areas of ag-relevant sensors for more efficient application of fertilizer and water, and the development of an autonomous planter capable of seeding a 5-acre field all on its own. But now, they've set their sights quite a bit higher, growing food in space. Yufeng, Santosh, David, and their research team were awarded a 2-year Grand Challenge grant from Nebraska's Office of Research and Economic Development to find ways to sustainably grow food in space. In the short term, they plan to develop a center dedicated to the study of space agriculture here at the University of Nebraska, the first of its kind at a U.S. university. I'm really excited that you all are here, so let's dive in. To start off, I'd just like you to tell us a bit about yourselves and your work up until this point, how you got here.
Yeah, so my name is Santosh Pitla. So my research is in agricultural robotics and automation. So I think robotics and automation have potential to be really good climate smart agriculture tools. So that's kind of my research has been the last 6-7 years. So now we are looking at how can we grow food in space. So I also think autonomy and robotics will play a huge role in how we grow food in space.
Yeah, so my work has primarily focusing on sensing and instrumentation, part of the agricultural engineering. So I develop sensors and looking at sensors from other sectors and in trying to find their new use in agricultural settings. So particularly looking at things like imaging sensors or spectroscopic sensors, and hopefully we can improve our efficiency using those sensors for agricultural research and also production agricultural. So I'm also a proud member of the DWFI, faculty member.
David Jones, and my work has largely been in systems modeling and describing those complex systems mathematically and graphically. And as we look at how we are conducting agriculture, and then we project where we are now to what it would look like in space, that's a very exciting way to describe those systems, from almost a limitless area, if the planet Earth is limitless, to a very confined space while we're in space. And being able to bridge between what we do on Earth versus what we would project to do in space. And hopefully we will learn in both directions.
Thank you. So growing food in space seems like such a long shot from an outside perspective and something that would be really hard to do. So walk me through how you landed on this Grand Challenges idea and why you decided to actually tangibly pursue something like that.
Well, I'll start with the last part first. Why? And it in part goes back to where we need to learn from our investigations in space to how they will benefit us now in the short term. And we need to challenge some of the solutions that we're wanting to deploy now and use the space application to test them to see if they hold up to the rigors of that. And so it becomes in some ways a stress test for the solutions we're offering now. And that is one of many motivators for pursuing that.
Well, one other motivator really is, we talk a lot about climate change, right? So the increase of the temperature or the higher frequency of those extreme environments, such as rainfall, drought, almost natural disaster type of events. So, when we talk about the climate change, the extreme environment, what else can be more extreme than the space environment? So we really think that this is a very good test ground and a use case, if you will, that we can really looking at what are that extreme facing the agriculture potentially in the future. We are not talking about 3 or 5 years or 50 years down the road. We're probably talking about hundreds of years or thousands of years down the road. And, being able to speculate what it is and, being able to conduct research on this environment would be really exciting.
Yeah, I think in addition, if you think about last 10 years, we have made many advances in rocket launches. There are more and more missions to Moon and Mars. And in the next 20 to 30 years, having a manned mission. So then what is the biggest thing, People will be there on Moon and Mars. Then how does the ag and food system look like? So that's kind of one of the motivators. And also this extreme environment, like Yufeng mentioned, how do we grow food in extreme environments, including extreme environments on Earth? How can we make some of the extreme environments on Earth productive? Is there an opportunity there? So those are all the motivators.
So I think you touched on my next question in this question, but if you could expand on that a little bit, what would you say to someone who might wonder why we should care about growing crops on other planets when we already have so many challenges here? Shouldn't we try to fix those first? Mm-hmm. What would you say to them?
Well, there's a lot of reasons that why we should do that, even though that we have a lot of problems existing right now here on Earth. But I will touch one, and then Santosh and David can, join. And so, one of that would be really thinking about how we can conduct agriculture more efficiently, right? So, we know here we need water, we need nitrogen, we need phosphorus. So those are the biggest threes that we manage, essentially on a constant basis, figuring out ways how to manage and use them efficiently here on Earth. Now, if you look at the space environment, there is no water, there is no nitrogen, no phosphorus in easy way that we can use it, right? So therefore, I think one of the big challenges we're facing when we talk about a space ag is going to be, well, how can we utilizing those resources more efficiently? I think as soon as we learn how to do that, and that would essentially we can bring back the technology and discovery there to here to solve the problems that we are facing right now.
Yeah, I think what Yufeng said, is absolutely right. But also it's about a change in our thought process, So here on Earth, we still have a lot of abundance in terms of, nitrogen and water. But then in the coming years, it might not be the case, right? So to have a better appreciation of how things can look like in extreme environment, I think we can look at space, where things are very extreme and very resource deficient. So, can we manage to grow food there and with minimal resources? And that will have a lot of implications, to do things better on Earth as well.
So what I'm hearing is that the things that you learn about space can be easily transferred to Earth, since that's an even more extreme environment. So that's interesting.
There are past histories, right? So about how exploring space and trying to grow in food in space, so develop the technologies that actually have a huge impacts on the Earth agriculture. So I'll give you one example, that's LED. So LED lighting, widely used for urban farming and indoor farming. And that is technology being developed by the NASA back in the time when they do the space agriculture research.
Interesting. I didn't know that. As evidenced by me not knowing that, my knowledge of space is fairly limited beyond the fact that apparently Pluto is no longer a planet. So can you tell us a bit about the physical conditions in some of these areas in space that might be viable for humans to live and grow food? So what are some of those areas, and what do the land, water, and climate look like that you're dealing with in this project?
Yeah, I thought about this when in the context of teaching right now. So when we, in our teaching our courses, we always, okay, assume gravity is. Well, we have to update that assumption about gravity, for example. Then you go to atmospheric pressure. We sort of assume that we're one atmosphere. Well, we have to update that assumption when we're in space. Then it goes to the amount of radiation and the nature of the radiation that the physical system is encountering. And those are three big ones. And depending on where you are, the moon, Mars, somewhere low Earth orbit, then you start adding to those changes.
One of the big environmental shift you will see would be the substrate, the soils, right? So here on Earth, we know, they are the mixture of minerals, but they also have a lot of organic matter, up to 5-6% for agricultural soils in it. And those organic matter turns out to be extremely important for the plants to grow. Now, when we go to the moon and Mars, there is no organic matter in the soil. It's all purely 100% mineral, right? And there's no water content in it right now. There's no liquid water. There might be frozen water mixed together. And then you go think about, all the heavy metals, the very high heavy metal concentrations in those regolith. And that's something that's going to challenge our plants too. And if you go to Mars, we know that there's something called a perchlorate, so which is highly toxic for the living systems. And that's up to 0.5% of those perchlorate in the landing site that we know right now. So therefore, all those would cause challenges for grow plants, and those are why we get excited, because those are if we can solve those problems, man, I cannot imagine what else we can solve here, right?
Yeah.
Something as simple as irrigation, right? So Water for Food Institute, this is a perfect example, right? We know how water flows here, but how about in zero gravity or less gravity? How do water flow? It's not easy. This is what one of the NASA scientists told us. Irrigation is a big challenge in space. That's why I think we kind of are used to, good conditions here, and we don't think about the gravity, we don't think about the toxicity, so we need to rethink how do we irrigate crops in space. So that's a big challenge.
So you mentioned gravity and soil and water. I want to hear what each of you thinks is the biggest challenge in growing food in space that you think will be the hardest to overcome.
I can go first. I think, I am sort of kind of usually like to approach this in a research mind. So therefore, I search literatures and read the literatures, right? So what the literature tells us is, so the most frequently studied interaction of plants and the space environment would be radiation, right? So we know that radiation changes the DNA, it damages DNA. So, and then there is a problem about the type of radiation, some of them ionization, some of them, like ultraviolet, we know that's going to cause damages. And the amount and the quality of the radiation is important, right? As you go through, go to the Mars and go to the moons, and you're going to, experience different type and quantity of radiation. And one other thing is we don't know, we never, we don't have enough experiments done to ask whether the DNA damage is heritable or not, right? Because we usually don't do generational studies. You see those damages on the individual, but you don't know if they reproduce, are you going to have an accumulative effect, right? Because that's important. If we truly want to have a settlements on the Mars, then we have to be there for maybe a couple of generations, maybe a lot of generations. So what's that's going to impact our plants and the crop and the food system eventually. So that's something always gets in my mind.
There's a long list, but to Yufeng's previous statement about the lack of organic matter is going to be a major challenge. And the cropping system's first purpose may be to produce organic matter, right? And so thinking about how we stage the deployment and ramp up to where we can grow that first acre of corn, for example. That's part of the strategy that we hope to think through.
Mm-hmm. Yeah, I think for me, robots need to get to the Mars or Moon and start producing food before humans can actually go there. And how do you scale these food production systems? And how do these autonomous systems look like? They need to be, really, really robust. They cannot fail. So how many human interventions are needed? The last thing astronauts need to worry about is growing food. But how can we develop this perfect high-tech farm hands, if you want to call it that way, So it's kind of what I keep thinking about.
Yeah, the robot farmer.
The robot farmer.
Yeah. What are some of the agricultural technologies or principles that exist now that you see as a natural fit to bring to space? What are the low-hanging fruits that you think will work well under those extreme conditions?
So for me, I think greenhouses here is it's easy to translate to a greenhouse in space. I think the big thing is the energy requirements. How does it look like? So to begin with, I would say you have to grow food in a controlled environment. So controlled environment principles that you see here will be applicable there, with some changes in gravity, and so on and so forth. I think we're not going to directly go and try to grow food in outdoor conditions there. So the any CEA principles, I would say controlled environment ag principles will be applied.
Yeah, so, to me, I think because I'm a sensing guy, I'm going to promote for sensing, right? So Santosh already sort of indicated that, when you go to grow, you have to rely on automation and robotics. So the way that I envision this is, you're going to you set up sensors and you use automated inspection of how fast they grow, how well they grow without the habitants yet, right? And then, you set up the camera system, you analyze the physical amount of the biomass, for example, and you also look at the quality, right? So NASA really seriously consider this is, nutrition is number one thing that, it's important to keep all the astronauts healthy. Therefore, things like phytochemicals, the active compounds that in there that actually have the health benefits or have the medicinal benefits, those are usually the things that you can probably quantify with things like a hyperspectral imaging system, right? So therefore, NASA is kind of looking into those technologies. How can we deploy those automatically to give you a feedback without the presence of the human yet?
Now we're talking about robot researchers too.
Yeah.
Well, I would say the principle that word got my attention is we will use space agriculture to explore and develop the principles of a circular economy, because we will not want to waste anything. And, DWFI, let's focus on water. We will never dissipate water. If we do, there's something wrong. And we had this discussion last week with visitors and, this audacious goal of an acre of corn. And they highlighted, that's 3,000 to 4,000 gallons of evapotranspiration. How are you going to do that? And I was excited because that's 3,000 or 4,000 gallons of purified water that's just gone through the corn plant. Right now the challenge is to recover it and harvest it and repurpose it. So that's an example. Now, if we do that, how do we do it? How do we know we're successful? What are the principles of success or the measures of success? And we need to use this setting to help us better understand what's going on Earth and how to improve those systems in space. And add to the list water, oxygen, protein, nitrogen, phosphorus. Our laundry list is very long.
So understanding that there's a lot unknown about this area of research, can you give us a timeline as to when you think growing food on a space station, the moon, or another planet might become a reality?
I have some note here. So I'm gonna give my 2 cents. Okay, so NASA's already did it, and some other space agencies, other governments, right? So they already do this at ISS, International Space Station. So International Space Station is the low Earth orbit. So therefore it's relatively easy, right? So, but they're doing it for, decades already, right? So I think the next step, which, is, I think we can probably do it in the next couple of years, is going to be beyond the low Earth orbit. So, that would be, 3,000 kilometers, right, away from the surface of the Earth, but still going around the orbit. And, you can do it on the CubeSat, small satellites, send the testing equipment to there to see if they grow, right? You can set up cameras and you can see it from the Earth whether they do it or not. So that's, I think, is a pretty immediate. Then the next thing is going to be on the moon, right? I think we'll have to probably heavily rely on like SpaceX and NASA, because they are the person doing the rocket science, doing the propulsion, right? Doing the, the spacesuit research. If NASA is on schedule, like if they can do the Artemis program and send the human being on the moon in the next 2 or 3 years, and then we'll be able to probably do this pretty, close near term, right? I'm not talking about having really 1 acre of corn outside for support thousands of people. I don't think that, but I probably have a small scale production in a protected environment. We might be able to realize that in a decade. So, and then the next step is going to be Mars, right? And then it's so far away. It's I would bet probably in half a century, but no one can predict that yet.
Yeah, I think the fruit is already grown on the ISS space stations. I read an article where they're eating tacos. They grow jalapenos on the ISS. But one thing to note is that these chambers are the size of a microwave. It's very small. So I think one of the things that we want to do is speculate, what technologies do we need to scale this production, so that when we are on moon, we can have a greenhouse, how does it look like? So those are all the aspects we are thinking about. How do you scale the food production system?
So your project not only includes just the three of you, but a pretty diverse team. Can you talk about why it's important to have such an interdisciplinary team working on this challenge, and who all is involved? Who all have you brought into this?
So let's say we are successful landing on moon and we are using all the resources that moon has, right? So then do other countries have claim on it, or is it just United States? So we are not experts at that. So that's why we have space law. And then let's say we have a human settlements on the Mars and there are kids born on the Mars. Then are they from Earth or ancestor? How does it look like, right? So all of this requires a lot of speculation and imagination. So we have Carson Media of Arts faculty from there, social scientists. And then what is the ideal plant to eat? Like for the best human health, what is the ideal food? Not just physical, but mental. So for that, we have nutritionists and food scientists on the team. We are engineers. We don't have all the answers or all the questions, Are we solving the right problems in some cases, So that's why we have a strong multidisciplinary team. Yeah.
Probably best to imagine these scenarios before they become a reality.
And that imagination, quite frankly, is a big deal, because we are going and we're looking at applications that we haven't encountered. And we need to have really good imaginations about what could be there. One, to project or predict the problem we're solving, but also to help us have a bigger solution space, right? We need to come up with solutions that we're not even dreaming about yet. And that's another exciting thing about this, and what you get when you have truly transdisciplinary problems with a transdisciplinary team engaged. And that's what we're trying to live out in this project.
Essentially, this planning grant, we started with some of the departments that's already mentioned. But, as we move forward, we start to realize, our team is still not big enough, right? Because we need to include more different disciplines. So we'll have different engineering departments from UNL, and we'll probably have more involvement in food science and technology because we just realized, well, that's so important. Maybe also, the plant genetics and those study space plant biology have those fundamental understandings just so important for our success to grow food in space.
So DWFI is a global institute, so we're always thinking about these projects in a global context. How can a country or government support or contrastingly harm or hold back this work? How do you navigate all that? You mentioned a little bit about that, but can you expand on some of those ideas?
As far as I know, some of the work, like the Artemis program, it's not just the NASA, right? So it is a truly intergovernmental agency collaboration. So there's the European Space Agency. I think there's a Japanese Space Agency, right? So, at least from now, that the way that I see is collaborate. There's a lot of collaborations intergovernmentally, but certainly the issue of the law, the issue of the if you explore, and then there's a resource claim and settlement, the boundaries. That's something that I can't predict yet.
Mm-hmm. Mm-hmm.
Yeah, I would agree. I don't really know if there's much. I think we're still exploring that. Mm-hmm. And so think about it from the standpoint of everyone who is approaching the space problem, whether it's agriculture, food, or launch, they, by necessity, sort of narrow it to a space that they can actually impact. So part of the magic of the space programs in the past is there have been coordinators, if you will, that make sure they all fit together in a way that they can actually accomplish the mission. And I think when we get off on this path of agriculture in space, we're going to have that same phenomenon. And so what I see is we need to understand the work that's going on elsewhere, how that work has been scoped and scaled so they can actually do something, and then the ability then for someone, maybe us, to figure out how to put all those pieces together and fill the gaps so we can actually accomplish it. So I think the biggest help is transparency and collaboration, and the biggest harm would be lack of transparency and collaboration.
Yeah, I think it's interesting that countries collaborate excellently whenever it comes to space research. Or if you think about International Space Station, right? There's people from all over the world, right? So they're looking down at Earth, and I'm like, why are people fighting on that? But also specifically to our project, since we're dealing with talking about food and agriculture systems, I think there are amazing ag systems everywhere in the world, which sometimes we don't do it here in the US, Here's an opportunity to see, what foods are ideal for space, So I think it is a great opportunity to enhance international collaboration in the food systems. Yeah.
So we know what the end goal is, but now that you've been awarded this funding and you've had some time working on it, what are the next steps to the project and some upcoming milestones that you're looking to hit?
Yeah, one of my major focus would be, so this is a planning grant that we got from the UNL's Grant Challenges Initiative. So it's a two-year grant, 2-year project, and we are at the 1.5 year mark. And essentially what we wanted to go for is next year we would like to submit a full-scale catalyst grant. So that would be much larger in scale. And the grants that we have, if we get it, is actually allow us to do research, education, and outreach activities in space ag. So that would be one of the immediate milestones we wanted to do next year.
And one of the milestones we just hit is our SpaceX symposium that happened last week, and we brought in people from NASA, space robotics companies, other universities who are working in space ag research. So we learned a lot, and we were surprised how successful it was, because a lot of ideas, a lot of collaborations, and so how do we include them is also in our proposal, and our planning is some of the next steps.
Yeah, and I would echo that symposium we held. It highlighted a couple of things, and one is where we are in relation to other work that's going on. And some we're lagging, of course. But the encouragement that we see from the participants was affirming that there's a lot more work to be done and that we have some expertise and some opportunities to really take some leadership in this. And it's going to come in two folds. One is, we've talked about here, is the systems modeling, the robotics and automation, the sensing, but also putting the whole system together in a way that actually moves the needle, gets us closer to that goal. I think the other outcome will be, this is a big investment, and the university is going to make a decision whether it's worth it or not. And it's, in some ways, it is about the research, but it's also about, does UNL want to invest in this effort of developing agriculture for space? And it's going to be a great discussion.
Well, those are all the questions I have, but I also want to give the opportunity if you have anything we didn't discuss that you wanted to comment on.
Well, I would like to add is along the way, right, in this 1.5 year, we pick up 2 graduate students. Mm-hmm. So their name is Hassan and Cassie, mm-hmm. and I think they are doing wonderful job. So mm-hmm. That's also part of how the university investment is important, mm-hmm. is to essentially train our graduate, to provide this opportunity on the ground to train the graduate students, mm-hmm. and they essentially, I can see their growth, and then ultimately mm-hmm. turning them into a better person. Mm-hmm. So that's the investment well spent from my perspective.
Yeah, to me, I think there is nothing called a Center for Space Agriculture anywhere in the U.S., and we want to be home for that. Mm-hmm. So where we do this transdisciplinary and multidisciplinary research on how to grow food in space. So. It's a really bold idea, as you know, and we are thankful to ORED for supporting this bold idea. And the success with our symposium, it's a testimony showing that a lot of people are working in this area too. So I think the Center for Space Agriculture will build a lot of foundational work, research that needs to be done in this area. So
let me echo on that, because this work is going to take place somewhere. And the question is, again, what is Nebraska? How is Nebraska going to take part in it? And one of our partners that was here last week, one of the things she showed was a map of where their facilities and operations were, and there was nothing in Nebraska. And that was her particular case. But she went on to say, she said, oh, by the way, she said, we hire as many Nebraskans as we can to do this work. And so I guess that's the other thing, is that we, as a state and a university, are going to be involved in this work. The question is it going to be here, or are we sending our talent elsewhere to work on this?
Thank you again to the three of you for coming in today, and it was a fun discussion on a really interesting topic, and I learned a lot. So congrats on this exploratory award, and good luck on the next round of funding that you'll be looking forward to. So I'm excited to see where it all leads. So thank you.
Thank you for having us. Yeah.
Thanks for joining us this time on the Doherty Water for Food podcast. Make sure to visit our website, waterforfood.nebraska.edu, to view show notes or subscribe so you don't miss future episodes.